Binomial distribution. Earlier in this unit, we learned about random variables and how they are used to model unknown quantities in statistical analysis. A special type of discrete random variable that we are going to learn about is called a binomial random variable. A variable is considered to be a binomial random variable when the following conditions are met. There is a set number of trials, in other words, a finite sample size. In each trial, the event either occurs or does not occur. In other words, it's a success or a failure. The trials are independent of one another, meaning they can't rely on one another. And the probability of occurrence in each trial is constant and remains the same. An example would be when the number of people who are left-handed in a randomly selected sample of 50 unrelated people. Let's try an example. The random variable C is defined as the number of correct guesses on a 20-question multiple-choice test. Is C a binomial random variable? Explain. Well, we have in this question, it's a multiple-choice test, okay? They're either correct or incorrect. So you have two outcomes, your success and your failure. And each question on a multiple choice test is independent of one another. So therefore, yes, this is a binomial distribution or a binomial random variable. And we do see on this slide that yes, we have a binomial random variable. One can get a correct or incorrect answer. In other words, the success versus failure. When we were thinking about it, I wrote a C and an X. There are 20 finite number of trials or questions that you have to answer on this test. And the trials are independent of one another. And the probability of success is always the same. When it's a multiple choice test, if it's got 4 answer choices, it's 25%. So this truly is a binomial random variable. Here's another example. The random variable J is defined as J is equal to the number of jacks after taking 2 cards from a standard deck without replacement. Is J a binomial random variable? Explain. Well, if you think about the number of jacks in a standard deck of cards, there are 4 jacks out of 52 cards in a deck. You got the Jack of Hearts, Jack of Diamonds, Jack of Spades, and Jack of Clubs. So if you are trying to get the number of jacks, the probability of getting a jack in your first card is this exact fraction, 4 out of 52. If you did get a jack for your first card, then the probability of getting another one would be the 3 remaining jacks out of 51. So this is again, if dealt 1 jack. Okay, if we take a look at this from another perspective, we would, again, for our first card, have 4 out of 52 to begin. But let's say you are not dealt a jack. If not dealt 1 jack the first time, well, then you still have 4 jacks in the deck of cards, but you have 51 cards remaining because of the 1 card that's in your hand that you have been dealt. So because there's the without replacement, and these 2 probability options are different from one another, no, this is not a binomial random variable. And as was shown on the last slide, no, this is not a binomial random variable. The trials are not independent of one another because after drawing a card, the number of cards remaining for the second card is 51 instead of 52. And this makes the probability of a jack occurring being 4 out of 52 times 3 over 51 if you are dealt a jack the first time, or it's 4 out of 52 times 4 out of 51 if the first card drawn or dealt is not a jack. And as you can see, because the probability of occurrences in each trial is not constant, this is not a binomial random variable. Let's try another example. The random variable j is defined as the number of jacks after taking 2 cards from a standard deck with replacement. Is j a binomial random variable? Explain. Well, this time, when a card is taken from the deck, we're observing it and then replacing it. So we're putting it back. So to get a jack, or the probability of getting a jack for the first card would be 4 out of 52. And since we're replacing it, we're still going to have 52 cards in the deck. And regardless of whether or not the first card is a jack, there are still going to be 4 jacks remaining in the deck. So because this fraction, or the value found for calculating the probability, does not change, we do have independent events. And we also have success, which is the jack, and we have failure, which is any other card. So because the events are independent each time, and we have that success-failure option, this is indeed a binomial random variable. So yes, it's a binomial random variable. And here's the solution written out. Yes, it is a binomial random variable. By replacing the card, the trials become independent of one another, and this also makes the probability of occurrence in each trial constant. So the probability of getting a jack 2 times would be 4 out of 52 times 4 out of 52.